All right, so we're going to be moving on to the next section. So we're going to kind of take a lot of the things that we've been doing with trig ratios, and we're going to now apply it to a circle. So this first part is about trig ratios of any angle. So the first thing, if you look at your circle, um, we know that we have radius r because that, in a sense, is what you can see labeled um, right here from the origin out to the side of the circle. And we know that right now we're going to say that this is just one point on our circle. So if you kind of read through this, you know that theta is in standard position. So we have our initial side, and then this radius is where the angle ended. So that would be our terminal side, and we're going to focus on theta. And what happens is we're going to be starting to figure out the coordinates of all of the points located around the circle using trig ratios. So the one big thing here that you're going to hear me say a lot is to drop a perpendicular from that point xy to create a triangle. So in my ugly redness here, we have a triangle that is kind of within our circle. And you'll notice if you graph a point, you have to go over to the right, and that is going to be x because that's our x coordinate. And then you would go up y units. So it works out perfect that the xy point gives us the adjacent side to our theta is now x, and our opposite side from theta now has a length of y. And then the hypotenuse would be the radius of the circle. So we're going to use this triangle to kind of answer the questions below. So I'm going to pull this up now and shrink it a little bit so you can kind of see what's going on. But if we now have to figure out the 6 trig functions for any angle theta, right now let's look at our triangle. So what we have is sine. So since sine is opposite over hypotenuse, that would be the relationship of y, or the y coordinate, we can say, over the radius. The cosine of theta would be x in the triangle, which is the x coordinate of the point, over the radius. And the tangent would be y over x. So that's opposite side over adjacent. Now keep in mind, x cannot equal 0, otherwise it would be undefined. Okay? Now the cosecant, secant, and cotangent, we just have to worry about reciprocals. So the reciprocal of cosecant, right, is the reciprocal of sine. So this would just be r over y. And this would have to happen when the y coordinate is not 0. Now, if you're wondering why I didn't worry about it over here, the radius, y'all, can't be 0, or we don't have a circle. But with xy coordinates, you can have a 0 in your coordinate. You know that. So our secant would be r over x when, that's an r, I'm sorry, when x is not equal to 0. And our cotangent would be x over y when y is not equal to 0. So we're going to use these trig ratios to do a couple examples on the next page. Okay? All right, so let's apply what we just talked about on the front page. So we know in example 1 that negative 4, 3 is a point on the terminal side of an angle. So what that means is that you know this is your initial side, and we rotated this angle, and this is your terminal side. So negative 4, 3 is a point on that terminal ray. So what happens is, I've kind of already done it for you, but what I've done is I've dropped that perpendicular from that point to the x-axis. You can see that right angle symbol. Now what happens is, remember, this r is representing your radius, and then we know that since we went to the left 4, I'm going to keep putting negative 4, and then we went up 3. So what happens is you have this right triangle, and your theta is basically that angle that is tucked in between that radius and the x-axis. So there's your theta. So if we fill in what we know already, we know that x is the x-coordinate, which represents the adjacent side. And I know we can't have a negative length, but we're not really talking about a negative length. We're just using this reference triangle to help us. So the x-coordinate is -4 and the y-coordinate is +3. Now we need the radius. Well, you guessed it. You can either use the Pythag theorem, or there is a popular Pythag triple that when you square 3 and you square 4 and you add them up, it's equal to 25, which is 5 squared. So if you know that, no sense in showing it, we know that our radius, aka the hypotenuse of this right triangle, is 5. So now we can piece together what we just did on the front. So you can either look at your triangle, but if I know my relationships from the front, the sine of theta is going to be the y-coordinate over the radius. Therefore, the cosecant is its reciprocal. The cosine is going to be the x-coordinate over the radius. Therefore, secant is its reciprocal. And the tangent will be the y over x. Oh, sorry, that's supposed to be +3. Oh, my bad. So 3 over -4, or -3/4, and so the cotangent is -4/3. So really that's all we're going to do right now with that information from the front. So I highly suggest you pause. I know you won't listen to me, but I would pause, try these two right now on your own, number 2 and 3, and then check back and then push play and make sure you're good. Okay? All right. Now that you have these two done and tried them on your own, I definitely am going to draw a picture, and I suggest it until you can start doing this without the visual. But if we're going to look at the point -12,5 on the terminal ray of our standard angle position, -12,5 is going to also land in quadrant 2, like our first example. So basically you have this angle and it rotated around, okay? So what happens is we now need to drop that perpendicular. You always drop to the x-axis. Now, what we did is this means that went to the left -12 and we went up 5. So we now have the opposite and adjacent. If this is our theta, okay, and then this would be our radius. So right now we know that our x-coordinate is -12, our y-coordinate is 5, but we need our radius. Now, if you are not aware that this is another Pythag popular triple, that's okay. If you don't know it, then you are going to have to use that Pythag theorem, and you would do legs squared plus legs squared equals the radius, or the hypotenuse, squared. And I know you can probably handle a lot of that on your own. So when you do that officially, the radius would be 13. So what happens now is we can use the same ratios. So our sine of theta is y-coordinate over the hypotenuse, aka radius. So we can easily do that one. The cosine of theta will be the x-coordinate over the radius, or hypotenuse, and then we have the reciprocal for secant. And then the tangent would be that opposite over adjacent, which in our minds would be the y-coordinate over the x-coordinate, and then we have the reciprocal. So if you notice, our sine and cosecant, those ratios are positive, but the other 4 are negative, and that's going to mean something in a minute. So I just want to kind of plant that seed in your head. Now let's take a look at number 3. So once again, I am going to draw myself this picture, and I'm going to plot that point left 3, down 6. So this time we are in quadrant 3. So once again, we have our initial ray, we have our terminal. This angle was rotated about. So I'm going to drop that perpendicular up this time. I can draw straight. And you always, that's supposed to be a 90-degree symbol, y'all. And what I always want to do is I want to make sure that I'm drawing to the x-axis. So again, we went to the left 3 and down -6. Now I'll say it again. I know you cannot have a negative length, but remember this triangle is really just not there. We're drawing this reference triangle, as we call it, in pre-calc to make sure that you visualize where this angle is really ending up. So here's our theta, and once again, we need to find our radius, or what we would call the hypotenuse. Now in this problem, we already know that our x is -3, our y value is -6, but this time we're 3 and 6, I don't think, are a lovely Pythag triple. So we're going to have to use that Pythag theorem. So 3 squared plus 6 squared equals radius squared. And that's 9 plus 36. So I know you can handle this without me, but just in case, you want to simplify the square root of 45, I believe breaks down or simplifies to 3 radical 5. So what we have going on here are the pieces of information that we need to fill in our trig ratios. So let's hammer this out here. So our sign, once again, would be opposite, which is -6, which happens to be our y coordinate over the radius. Uh-oh. So when we have -6 over 3 radical 5, you're going to have to, I personally would probably simplify this first to -2 over radical 5. Then I would rationalize the denominator. So your final answer should be -2 radical 5 over 5. Now your cosecant would be the reciprocal, and that's just radical 5 over -2. Your cosine, all right, I'm going to do that in a different color so it doesn't all blur together. Your cosine is going to be your x-coordinate over that hypotenuse, which is 3 radical 5, or the radius. Once again, I would probably simplify this down to -1 over radical 5, and then multiply by radical 5 over radical 5 to rationalize your denominator. So this would be negative radical 5 over 5. I'll circle that. And then the secant is just the reciprocal, so that would just be negative radical 5. Our tangent is your y coordinate over your x coordinate, so that is just 2. And cotangent's reciprocal, and the reciprocal 2 is 1/2. So these are your 6 ratios that you should have. Now notice that this time tangent and cotangent, those ratios are positive and everything else is negative, okay? So I'm going to pause the video here. Actually, I'm going to stop it. And then there will be a part 2 to this video that you need to watch to continue and finish these notes for our next class bell. So just go on to the next video.